When one thinks of virtual ecosystems in which agents live, cooperate, compete, and eventually die, it is hard not to think of video games. There is a continuum between ecosystem as artwork and simulation-based games. There are simulations where most players are humans controlling characters in a virtual world. Open-ended games with a given universe and a few rules originated in the 1970s with role-playing games such as Dungeons & Dragons. These were adapted to computers as soon as networking became good enough. An early example is the multi-user dungeons that ran from 1978 to 1999 and started with ARPANET well before the internet. MMOs, or massive multiplayer online games, are still thriving today. There are also some simulations where humans play gods or special roles in which they direct and manage groups of agents or are in control of a whole ecosystem. SimCity, first released in 1989, is an open-ended city-building game in which the player needs to decide of all the biotic and abiotic elements that come into play in a city: roads, infrastructure, waste management, taxation, etc. The player's role is to try to manage the growth and survival of this complex ecosystem. The term emergent gameplay is sometimes used to describe these types of gameplay. It refers to complex situations in video games, board games, or tabletop role-playing games that emerge from the interaction of relatively simple game mechanics. Neither art nor game, a computer virus is also a type of agent, one that considers the internet and the computers connected to it as its ecosystem. Viruses and worms spread with the advance of microcomputers and computer networks. Unlike the other systems we have studied so far, the environment that a virus lives in is not a simulation of an environment, but it is the actual digital ecosystem provided by modern and ever-changing networking computing technologies. Viruses and worms are outside of the scope of this class, but they remind us of Christopher Langton's warning from 1990. He said, "There is a caution here that we all must attend to. Attempts to create artificial life may be pursued for the highest scientific and intellectual goals, but they may have devastating consequences in the real world if researchers do not take care to ensure that the product of their research cannot escape either into computer networks or into the biosphere." Whether in science, art, or entertainment, artificial life encompasses the creation of imaginary beings and lifelike artifacts. Most of us have ceased to believe that we are the puppets of some gods, but we are certainly fascinated by the possibility of becoming the gods of our own creations, of our own virtual worlds. Nature has been called the greatest architect of forms and processes. We can borrow and abstract nature's processes, which might inspire us to create new ones. Alan Dorin argues that the most interesting works of generative art exploiting ecosystems for their aesthetic properties exhibit 4 basic properties: coherence and unity, the system has and maintains an identity through time; multi-scale temporal complexity, there are interesting dynamics occurring in several timescales; autonomous production of novelty, the system's search space or state space is vast and novel configurations occur autonomously; and finally, responsiveness to perturbation. The system is affected by and reacts to external perturbations. This is particularly desirable when the system is interactive and takes input from the audience. Virtual ecosystems are a type of artistic practice that is really contemporary to digital computers. A virtual ecosystem is not simply the virtualization of a creative task, as with most of the other systems we studied so far. Here, the virtual ecosystem does not really generate a piece. Instead, the artistic output is the appearance of the ecosystem, or the emergent dynamic constrictions that the agents create in it, like in swarm painting, or even the property of the system as a whole. In any case, it is a unique way to use computation as an artistic medium. Virtual ecosystems carry with them some of the fascinating beauty of the dynamic systems observed in nature. The class on advanced notions in generative art and computational creativity will cover more ecosystemic approaches to generative art and computational creativity by looking into systems that model the evolutionary dimension of ecosystems, among other things.